सगळ्यात मोठी गोष्ट म्हणजे लोकांना पिण्याचं पाणी त्याची फार मोठी गरज आहे आणि ती गरज भागवण्यासाठी या जलसंधारणाच्या कामातून निश्चितच सरकारला फायदा होईल. फिनोलेक्स इंडस्ट्रीज लिमिटेड आणि त्यांचे CSR पार्टनर मुकुंद माधव फाउंडेशन यांच्या वतीनं हा जो कार्यक्रम इकडं या माळशिरस तालुक्यात घेण्यात येतो आहे तो अतिशय उत्कृष्ट कार्यक्रम आहे आणि त्याबद्दल सर्व याचे जे काही भागीदार आहेत त्या सगळ्यांचं मनापासून अभिनंदन करतो. धन्यवाद.
Grundfos iSolutions brings the benefit of intelligent solutions to smart booster systems. Solutions based on intelligent and variable speed pumps, cloud connections, and integrated system control. These solutions connect to any building monitoring system, making them a fully integrated part of the communication suite. Grundfos iSolutions provides booster systems for any application need. Choose plug and pump solutions that are fit for purpose with easy installation and setup. Or application optimized solutions that can be customized to fit any needs within more demanding applications. So, whether you're looking for a booster solution for light commercial, intermediate commercial, large commercial, or industrial booster systems, Grundfos iSolutions delivers a solution that enables optimum efficiency, control, and comfort within commercial boosting applications. Grundfos iSolutions. Pump, cloud, services.
Huliot Group is a leader in the design and manufacture of advanced flow systems for commercial and residential buildings. The company offers a broadly comprehensive portfolio of sanitary system solutions that address the full life cycle of water flow from water supply to wastewater and infrastructure. With patented technology and state-of-the-art manufacturing techniques, Huliot Group offers innovative products that are available in each of the standard size and diameter options, and which deliver the highest standards of quality and reliability. The company is headquartered in Israel, and with its 5 global manufacturing and commercial subsidiaries, it serves an extensive customer base that spans over 30 countries worldwide. With a robust legacy of over 70 years in piping domain expertise, Huliot Group brings a profound commitment to always delivering service excellence and customer satisfaction.
Our home has changed recently, meaning it's not only our home, it's our office, it's school, if you can call it a school, it's a place to take a short walk. Our home is the gym. It's also the great outdoors. It's the place where we learned how to protect ourselves at a time like this, when everything happens at home. We at Juliote Group are doing everything possible, so when it comes to your home water flow systems, you can enjoy real peace of mind. For over 70 years, we've been specializing in the production of advanced flow systems, water supply, drainage, wastewater, and infrastructure. Now, as always, we do everything we can so that you never know we're there. In every home, all over the world. Juliote, for your peace of mind.
Global challenges require global responses. At Velo, we are playing our part and leading the way. The Velo Group is one of the world's leading providers of pumps and pump systems for the building services, water management, and industrial sectors. We move water with innovative products, smart solutions, and individual services. Velo provides critical infrastructure around the world. We fit out important buildings like hospitals and waterworks. We equip key industries and agriculture. Velo is the digital pioneer in its industry. As an innovation leader, we set standards, from smart production to our connected products. They allow us to achieve new dimensions of customer satisfaction and efficiency. Velo offers sustainable solutions while also taking social responsibility. As one of 50 sustainability and climate leaders and the winner of the German Sustainability Award 2021, Velo is committed to actively slowing climate change. And by 2025, all of Velo's production sites around the world will be climate neutral. Around 8,000 employees are the foundation of our success. They are the heart of Velo. Together, we can overcome the greatest challenges of our time.
Good evening, everybody. Can you hear me?
Yes.
All right. Thank you very much. Good evening, everyone. And I'm so happy and excited for the day which we have planned to bring some international case studies for all our members. And this is a good day. I can say to you all that we got a confirmation from Mr. Luke Leung. He was the MEP director for Burj Khalifa, which is an iconic building worldwide. People always love to go and see. And today we are going to see a lot of the inside story. So I'm so glad that a lot of people, more than 400 people had already joined us. And I can see a large number of people are coming in. And we are going to have a wonderful session. And it's a great evening. And thank you, everybody. And who all are, I can see a lot of good evening messages are coming in. Somebody's from Australia, somebody's from Netherlands, somebody's from America, and a lot of people are from different part of the world has joined us today. I welcome all of you. I can assume that you all are in a different time zone, but seeing your passion for plumbing is really motivating for all of us. And I can assure you that being a part of an IPA webinar committee, we will ensure to bring best of the best case studies for you, all of you. And I'm so happy to see that Luke has also joined us. It's a very early morning to Luke. Thank you, Luke. Welcome. Thank you very much. And so before we start the event, so I know everybody's excited and looking forward for it. I would request everybody, as we always do, please raise for national anthem. Can everybody rise for the national anthem, please?
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you very much. All right, before I move on, I can see our national president, Mr. Gurmeet Singh Arora, has also joined us. I think he's in the car, he's traveling somewhere. Earlier, he sent an apology that he will not be able to. Thank you very much, sir. It's a really great motivation for us that you have always been there with us wherever you are. Thank you for joining with us. I can see his network is, sir, you can hear us?
I have very bad connectivity. Please carry on, sir.
All right. Thank you very much. Thanks a lot for your passion for us.
Am I audible?
Yes. Yes, you are. You are. Yes.
Well, I would like to thank Esquire Luke Leung. It's 6:45 in the morning for him. Poor guy in Chicago, but he's joined us. Thank you very much, Luke. And please understand, ladies and gentlemen, that most of our metro cities and tier 2, tier 3 cities never built buildings above 7-story. And now we are building high to sky, 30-story, 50-story, and even going up 100 meters to 300 to 100-story, 300 meters, I'm sorry. And that's where the plumbing design, the flow rates, the pressures, the
Seems the network is
hydropneumatic systems and the firefighting. When you have a hydropneumatic or closed circuit, you have to look at electricity, and that's where Luke is going to also speak about how we are going to enhance make sure that the systems are fail safe, and therefore I think it's a fantastic topic. My only complaint is that this webinar committee is taking away all our good speakers from the Indian Plumbing Conference, but I wish this session success, and I'm sure you'll get more than 1,000 people on Facebook and live. Thank you very much.
Thank you very much, sir. Thanks a lot. Thanks, sir. Thank you very much. All right, moving on. I can tell you all that when I first interacted with Luke, it was last year when the pandemic started, and we both were on the platform of ASHRAE, American Society of Heating Refrigeration Engineers. Luke is a distinguished lecturer of ASHRAE. And when I spoke to him and we were discussing about this, and I told him, Luke, the movie which was made was a Mission Impossible. I think you guys made it a Mission Possible. I was always keen to run through a Mission Possible series with him so that we can bring more and more information for all our members. And Luke was very kind enough to do it. So thank you, Luke. Thank you very much. And we look forward for a wonderful day. Before I bring you on screen, I have our partner, Mr. Ram Kumar. He is the Deputy Regional Manager from Asher Pipes. They have always been kind to support us in all our events. So thank you, Ram Kumar ji. Thank you very much. And I give the dice to you, please.
Thank you, Sandeep. Am I audible?
Yes.
Yes.
Very good evening to everyone. It is nice to see a virtual presentation on a major important topic on high-rise buildings, especially for fire and plumbing. And India is coming up with a lot of buildings like Burj Khalifa, and some of the pipings which we manufacture can go into these type of buildings. So I'll just go to a product presentation of what we manufacture. So if you look at it, Astral as an organization have been divided into pipes and fittings, infrastructure, water tanks, and adhesives. So these are the main four portfolios which we have as of now. So if you look at the trend setting point of this is that, we were the first one to introduce CPVC pipes in India. We have done a lot of introduced countless innovation in the pipe categories. We offer wide range of products in piping categories. We have 6 manufacturing facilities and 2 units are still under construction, which I'll come up in a later stage. We also have 2 water tank manufacturing facilities and the third is under construction. Again, I'll come back to that in a later stage. We have 3 adhesive manufacturing facility in India and 1 in USA and 1 in UK. We have a robust network of channel partners. So if you look at it, anywhere you go in India, we have a channel partner there. And we also have introduced DWC and infrastructure projects for the infra segments, because infra is the it's where it's growing like anything. So we introduced those products also. This is the journey. I won't go much on it. Only thing is that 1996 we are incorporated, and till now we have been growing, and there's a lot of additions which has happened, including the plants. 2016 was the time when we got into Fortune India 500 companies. 2020 we appointed a new brand ambassador, that is Mr. Manvir Singh, and we also acquired some of the companies from UK and US. Again, the same thing, 6 manufacturing for 5 manufacturing for adhesives and sealants and 2 manufacturing for water tanks. Along with that, we have a lot of things we export to approximately 25 plus countries. If you look at the channel partners, you'll find that we are 850 plus distributors and 1300 plus distributors, both adhesives and sealants together. We also have a manufacturing plants in 3 countries. These are some of our awards and recognition. The latest one is we also got the Super Brand for 2021, the Consumer Award. And we have been getting this for the consecutively 3 years. So if you look at it, we have been a trendsetters in India, and if you find that everything which we have launched, we were the first one to launch it, and people started following after that. So we were the first to introduce CPVC pipe, then UPVC lead-free pipes were been introduced. Then we also we were the first one to introduce or list our pipe, CPVC pipe with NSF, then foam core PVC. Then low noise PP drainage system, we were the first to manufacture in India. Then lead-free column pipes. Then we started our manufacturing of our own indigenous CPVC compounds. And we were again first one in 2021 to become the first to introduce a water tank with antiviral copper shields. So if you look at the pipe manufacturing, pipe and fitting manufacturing, we have in Santej, Dholka, Gilot, Hosur. So each and every plant has a varied capacities. So our largest plant always remained in Santej, which is the main plant. Then Sangli also we have taken over an Rex piping. So there also we added the capacities. Sitaranj, again, a new piping manufacturing plant which we have introduced. Aurangabad, again, a water tank which we have taken. That is Sarita water tank has been taken by Astral. So that's how we have put our facility in Aurangabad also. Again, in adhesive, if you look at it, Santej, Rania and Unnao, where we have quite a capacity. Along with that, we have internationally, we have acquired 2 of the companies. that seal it in UK and seal it in USA. So there again, we have a quite a big facilities to manufacture our adhesives. So the upcoming plants which are there coming up is the Aurangabad plant, wherein we'll be manufacturing our pipes there. Again, Sangli plant again we'll manufacture pipes that is Agri, SWR, and Georex pipes out there. And this plant will serve West and South Indian market. Again, in Bhubaneswar, we are coming up with a plant in Cuttack, wherein the pipes and fittings will be manufactured out there. So we are looking at a total capacity of 60,000 metric tons out there. These are the product range as of now we have into plumbing systems, the drainage systems, the agriculture systems, the fire protection systems, uh, cable protection systems, solvent cement. Do have the clamps and hangers and the insulation part of it. Industrial piping systems we do have. Water storage tanks, which has been recently launched in 2021, also is with us. As I said, we had in 2021, we had appointed Ranveer Singh as one of our brand managers, brand ambassador, and uh, he is the new face of Astral Pipes, India most trusted pipe. So these are some of the upcoming projects upcoming products which are coming up. That is Eco Pro. These are basically will be used for the reclaimed water PVC piping systems. Then we have underground piping systems as per IS 15328, which again will be newly launched. So we have the ISO certifications of both all our plants, which has been already done. So looking at the bread and butter of our piping system, we have CPVC Pro, which is our bread and butter. These are basically used for your hot and cold water plumbing system. We do have all the necessary approvals for it. We have the NSF certified approval. We have ISI mark, Uniform Plumbing Code also are listed with it. These are basically can be used for water temperature of up to 92 degrees centigrade. So we have a variety of ranges. We have from half-inch to 2-inch in SDR 11 and SDR 13.5. Schedule 40, 2.5 inch to 4-inch, and Schedule 80, 2.5 inch to 12 inches. We manufacture as per the different standards and specifications. This is the new product which we have recently launched in 2021, which is called Astral Multi Pro. This is basically CPVC, aluminum and CPVC. So the outer and the inner layer is CPVC, and the middle layer becomes an aluminum layer. So these are available from half-inch to 2 inches for both hot as well as cold water plumbing systems. So this is one of the new launches as multi-layered composite pipes for hot and cold water applications. This has been launched 2 to 3 years back, which is called the PEXA Pro. These are again for the internal plumbing systems. So your external remains with CPVC. The internal, once it comes, just like your junction box, we have a manifold, and from that manifold you can take out these piping systems, which is also called as PEXA Pro. These are available from 16 mm to 32 mm with brass as well as PPSU fittings. The jointing methods is very unique. You don't need a solvent cement, or you don't need crimping methods. It is majorly an expansion joints. So these pipes are also been approved for dialysis purpose. So in dialysis purpose, if you look at it, only the steel pipes is being used. Now these pipes are also been approved, and it's been used across different hospitals. This is our UPVC plumbing systems for cold water applications. So we have ranges from 15 mm to 300 mm, that is half-inch to 12 inches for both Schedule 40 and Schedule 80. Another wonderful product is the Silencio, which we manufacture. This is again a piping which has 1.9 density, and it's less than the sound which is getting transmitted is less than 10 dB at the 2 liters per second. So these are available from 40 mm to 200 mm, and we manufacture as per different specifications and standards. So if you look at it, these have been approved by IPMO. So Fraunhofer also approves it for the sound part of it, which is less than 10 dB for 2 liters per second. And we also have a Singapore laboratories services approvals, and watermark also is being put up. Sitco also has approved these products to be used in their buildings.
Kumarji, can we do it quickly?
Yeah.
Yeah, thank you.
Sure, thanks. So if you look at Silencio, the outer and the inner layer is PP, and the middle layer is the reinforced PP. So this reinforced PP is the one which absorbs sound. The outer and the middle layer acts as a toughness, and also inner layer becomes a resistance against hot water and chemicals. So this can take a hot water up to 95 degrees centigrade intermediately and 92 degrees continuously, and the pH levels which can handle is 2 to 12. This is one of the unique fittings which we have, the door fittings. We also have the foam core, which is basically used for underground drainage systems. Drain master is again for the drainage SWR pipes. So the ring fit as well as the push fit systems in these piping systems. Then we have T-Rex, which is basically used for underground systems. Then we have the our chambers, which can be replaced with the concrete chambers. So the sizes available are from 315 to 1000 mm. The height can be changed as per your requirement. This is again a wonderful product wherein we have a surface drainage systems imported from Germany, which is called Astral Hoerten, and these are basically used for your car lobbies and wherever there's a movement of vehicles or pedestrian. So outer areas these can be installed. So if you look at the installation part, there are lots of installation at different areas. You can install from airports to highways, so it can take a load from a pedestrian load to plane load. This is again another wonderful product which is called Astral Fire Pro. These are again UL listed product, UL listed piping, replacing your GI and MS systems. So these are available from 20 mm to 80 mm. And as per, these have been approved for light hazard occupancy as per NFPA 13. For cabling, again, we have WireGuard cabling, we have Telerex piping systems. Then for your vehicular movement, wherever vehicle movement happens, you have a multi-rex cable channels. These are agri pipes which we have from 2.5 kg to 16 kg. So different sizes we have it. Bowel is another column pipe, UPVC column pipe which we have. Case well again. We also launched HDP pipes. So as of now, we have 50 mm to 160 mm, but that can be increased to 500 mm. So we are about to manufacture this. Sandeep, 2 minutes.
Yeah, because we are running short of time, please.
Yeah. PowerFlex, again, a flexible PVC suction and delivery lines, which we launched recently. GeoRix, this is again a recent launch, which is being used for your water filtration or ground filtration of water. Chempro for industrial application, which are available from 1/2 inch to 12 inches. Aqueous Plus, again, UPVC pipes, which was used for industrial application for 1/2 inch to 12 inches. Insulation from 1/2 inch to 6 inches. Clamps and hangers. Your solvent cement, we manufacture all type of solvent cement used for CPVC and PVC. And this is again a new launch, which is the tanks, which are available from 500 liters to 5,000 liters. That's it from my side. Any queries or anything, I have my name and mobile as well as email ID. So you can always contact me. Thank you very much.
Thank you very much. Thanks a lot, Mr. Ramkumar. Thanks you very much. And I wish you good luck for Astral for bringing so many products under one roof. That's remarkable. Great. It's a proud moment for being an Indian company and doing so much excellent work. All right, moving on, where everybody I can see looking forward to hear from Luke and Mr. Isaac Kausa. I'm sorry if I'm pronouncing wrongly because we are not used to. So can I introduce Mr. Luke to everybody officially? Can I have his slide, please? Okay, Luke is a lead fellow. He's a ASHRAE Pandemic Task Force Commercial Team Leader, ASHRAE Building Decarbonization Team, Carbon Leadership Forum 2040, Net Zero Committee, AIA COVID-19 Task Force, BOMA Toronto Health Committee Co-Chair, Vice Chair of ASHRAE Environmental Health Committee, ASHRAE Distinguished Lecturer, former Chair of ASHRAE Technical Committee 9.12 on Tall Building, Expert Peer Review Committee for Council on Tall Buildings and Urban Habitat, former Board Director for USGBC, Illinois, Industrial Professional Advisory Council, Pennsylvania State University, Architecture Engineering Department, Industry Advisor Board for IN2 Startup Incubator Program with US National Renewable Energy Laboratory member. He's the wide firm director of the Sustainability Engineering Studio for Skidmore, Owing and Merrill LLP. His work includes Burj Khalifa, the current world tallest building, and other 4 of the top 20 tallest building in the world. Other work also included General Motors Global Headquarters, Beijing Finance Trade, US Census Bureau, US Air Force Academy, CCLD, US Embassy in Beijing, BBVA Tower in Mexico City, LGR Hall in Seoul, Korea, Master Planning of Xiong and the Millennium Plan of China, and numerous other significant tall and large projects. I can say I have another 2-3 pages, so I can read it for you, but I think that's enough to understand what he's going to bring on the table for all of us. So good morning to both of you, Luke and Mr. Ishak, and I wish both of you a good time, and I'm sure there are 450, 500 people are waiting to hear from you, and looking forward to have a wonderful session. And I tell all of you, I know after this presentation, you all will have so many questions. We will have a good question and answer session also. I request all of you to please put your questions in the Q&A session, and your all questions will be taken care and they will be answered. So Luke, to you.
Thank you for the invitation. Isaac, Kusa, and me, we will present the Burj Khalifa plumbing and fire protection. Isaac, do you want to share screen and share the slides? So what we'll do is I will try to talk about the more general aspect of the building design on the plumbing and fire protection. And Isaac will get into a little bit more on the technical detail. So do you want to go to presentation mode? So while Isaac is presenting or putting the presentation in presentation mode, I would like to take you back. I would like to take you back to the year 2003. Now, why is it significant? Because that was the time when we first received the RFP for a tall building in Middle East. Now you got to think about the context. It was 2 years, only 2 years after September 11, 2001, when the world was thinking about should we build taller building, and then we received this RFP from Dubai. Go to the first slide. So this is the location, UAE, where we got the RFP. And the RFP required SOM to provide a competition scheme for one of the tallest building in the world at about 800 to 1,000 meters. Can you go to the next slide? Oh, is it a PDF, Isaac?
Yes, Luke, it's a PDF.
You should use the PPT because there are a lot of movie file in there.
How do I use the PPT now?
Okay, you want me to share?
Yes, please.
Okay. Sorry about that.
It's okay.
So you can look at the screen here. at the time when we went out there at 2003, roughly Dubai at that corner is like that. It was not a whole lot of things, but you can see the difference in 2014. So there was a lot of question on our mind is why do you build the tallest building in the middle of a desert? Is it gonna elevate the land value around it to make the investment successful? As you can see today, it did exactly what it's supposed to do. Is by building the tallest building in the world in a location of the desert, it actually elevate the land value around it and become a very successful development. This is a picture of that in the nighttime. Now, Burj Khalifa is the tallest freestanding structure, and Council on Tall Building and Urban Habitats has 4 definitions of building height: highest occupied floor, top of the roof, top of the pinnacle, which is the antenna, mast, or flagpole, any type of elements that is on the top of the building. And then the sidewalk level to the structural top is the 4th category. Burj Khalifa is the tallest of all 4 categories. In terms of area, it's about 5 million square feet or 500,000 square meters, of which about 3 million square feet is at the podium and 3 million square feet at the tower and 2 million square feet at the podium. Now, this also housed the first Armani hotel of the world. So I remember there were times when the design team went to the meeting and met with Mr. Armani. The discussion is actually on the design team side. The toughest part is like, can you wear Calvin Klein to go to meet with Mr. Armani? So that become part of the design challenge of the team. In terms of program, at the bottom of the tower, you have the Armani Hotel, and then the surface residences from the hotel. And that's how it looks like. And then part of the residential tower is the luxury and service apartment. Some of them come with a pool. And the residential is here, as you can see on the screen, which is after the surface residences of the hotel, the luxury residential floors. That's how it looks like, the finish. And then the corporate suites. Now, initially, the top of the tower where the corporate suites are is actually also residential, but the management team of Burj Khalifa, they call around like their friends in town and said, would you like to buy an apartment at these levels? But what they received the feedback was some of their friends said, no, maybe not an apartment, but we would like to have a corporate suite up there. So that's why towards the end of the design stage, that was actually changed from residential to corporate suites, like office suites. This is not your conventional office, but executive office where the density is lower. And then all the MEP floors are in between the apartments and the office floor. Now, roughly about 40 stories, we have a mechanical floor. So when we think about the building, it is actually stacked 40 stories on top of each other to form this tallest building in the world. So from that thinking, it's actually quite modular, right? Every 40 story is a stack with a mechanical floor. And it has one of the highest observation deck in the world. And by the way, if you think about a tall building, part of the most profitable program is actually the observation deck. And you can think out why, because there's not a lot of expenses, but it actually worth a lot of money. People pay top money to go to the observation deck, and you don't cost you much, right? Only a person or two pointing to the people, you know, here is the elevator, that side is the men's room or the ladies' room, and maybe even a souvenir shop. So it's quite profitable as the observation deck. And that's what you see when you look down. One of the tallest or the highest restaurant in the world. And this is the chairman's suite on top of the tower where the chairman worked in there. Now we talk about this office executive suites. That's how they look like. So as you can see, they are not exactly your conventional office. And this is the picture I took when I looked down from the observation deck onto the floor. With that, I'll turn to Isaac Kusa on the systems. Isaac, do you want to share your screen? Isaac, are you there?
Yes, I'm here, Luke. I'm trying to find the screen here. Okay. Let me just start the presentation again and then scroll down all the way to the okay, so we're going to focus because the building is very large and we could spend hours talking about every single system. I decided I'd focus mostly on the domestic water system and the fire protection system and discuss those. And I will bring in some other items regarding for storm and sanitary and other systems as they relate to the presentation. Okay, so the first riser here is the domestic water riser. So initially when we did the calculations, the building consumes about almost 1 million liters of water a day. And one of the challenges we had is how do you provide water for an 800+ meter tall building? So in initial phases, we were discussing to use either an upfeed system or a downfeed system. And we had decided that one of the strategies we'd look into was to do a gravity system. So the idea was we would have the main storage tanks in the basement, and we would take pumps and transfer them up the building to smaller storage tanks. And as Luke mentioned, at each mechanical level, and then we would keep pumping it up the tower. The other thing we looked at was if we're pumping the water up, what is the how many pumps and what's the energy required to pump the water up? So one of the strategies we looked at was, why don't we use these tanks at each mechanical level to provide a gravity system? So what ends up happening is these tanks are designed to handle the zones below it. So the idea is, you know, hopefully you can see my screen here, the cursor. So we pump up the water up to this tank, and then we have another set of pumps that go up to here, and then they keep going up. And then what we do is we provide water down through an express riser, and then we come down and in most cases have a PRV station here. We come down and feed the water to the program that's required. One of the things we had was the building was split up into two systems. The hotel for the Armani suite were based on a separate system for the rest of the building. And the residential tower had its own domestic water system. And the fire protection was one system for the whole building, which we'll discuss next. But I do want to mention that the one thing that was unique about this design that previously has not really been used, and since then we have not seen many buildings use this, is that the transfer pumps from on the domestic side served a dual purpose. They were sized to provide the pumping capacity for the domestic water and the fire protection system, which thus required all domestic water pumps to be on emergency, which we will talk next. And in the fire protection system, it's a very similar approach. We have the same, since the tanks and pumps are shared, everything you see in blue is pretty much seen on the previous discussion, on the previous slide. And we had the same strategy as providing a gravity system. And one of the benefits of this gravity system was we were only required to have fire pumps at the top of the building to provide pressure for the first few floors before the gravity pressure allowed us to provide the required pressures for each zone. And then on the next slide, the other thing I just wanted to mention was, as you're thinking about this, we actually had an elevator that would go up to level 138. And then for the fireman, he would have to transfer and take another elevator all the way up. So this is one of the strategies that required us to maybe do the design a little differently than what you see in other buildings, because in most buildings, the fireman's lift goes from the basement to the top of the building, and there's no transfer and whatnot. Okay. One of the things we also had to do that was interesting was to help progress this project, we had to provide structural penetrations throughout the building, which in the US typically we would coordinate large openings with the structural team, which would be implemented on their drawings. And then any smaller openings usually is coordinated with the contractors, you know, after the construction documents are issued to the contractors. This is a typical floor of the residential. We'll show. So what we had to provide the owner and the contractors was something called the builder's work, where we had to locate every opening, and it had to be dimensioned, had to be sized, and the contractors would get this drawing and they would build off of these drawings. So one of the risks involved in this is we on the design team had to be correct and accurate. And the risk on the owner's side was once the installation was built or the concrete was poured in the openings, was they were limited in what they can modify and what they can add to the building. And then here's a typical corridor wall bay that in the hotel floors that we coordinated. So we would have we would try to put 5 or 6 openings, and each one would be designated for a trade. And sometimes these openings weren't used, so they were used as a spare for future.
And if you are wondering why do we need to do that, part of the reason is because the structural team decided to use high strength concrete. It's close to C100. Now, why do they want to do that? It's because of the sway of the tower. They figure out if we use the high strength concrete, the sway of the tower will not be more than like 4 to 5 feet and less than 2 meters each way. So we do not need a tune mass damper at the top of the building. What a tune mass damper is a device to prevent the over swaying of the building that can cause structural damage. So in this building, given a lot of building in the world has tune mass damper, the tall buildings, but in this one, though it's the tallest in the world, by using the high strength concrete to stiffen the tower, we do not have a tune mass damper at the top of the building. But the penalty is exactly what Isaac was talking about, is this high strength concrete, once they pour, you cannot drill a hole through the shear wall. So you have to coordinate all these holes in advance.
So as you can see here, we typically have 5 penetrations. Here we assign 2 150 millimeters for plumbing. Typically that would be like a hot and cold water. Sometimes a hot water return, or maybe a storm piping or vent piping as required. And we had 1 for electrical, 1 for fire protection, and 1 for IT security. And then we had 3 additional 100 millimeter openings for mechanical at the end of the corridor. I also wanted to mention, beyond what the other trades at SFOAM did with with openings. Plumbing also had to coordinate builders type openings with structures for the concrete tank walls, which we'll talk about the concrete tanks later. But you get an idea is, again, we had to provide exact openings for everything and provide this for them to design it. Because one of the things we designed were I know typically a lot of places use steel tanks for water, but in Burj Dubai, anything that had domestic water and fire, we had elected to use concrete tanks because we felt that we would be able to shape the tanks as required to fit the building shape, and also providing 8 or 10 inches of concrete thickness would provide a natural fire rating to protect the water that's in the tank. So at the end of the day, we had 150 penetrations that we had to coordinate with structures and provide to the contractor. So another thing we
by
had
the way, if I may, as Isaac, so one, you will think like designing that is an engineering challenge, and it is, but we actually spent 6 months. When you think about it, yeah, 150,000 opening. How long does it take to coordinate all that? It took us 6 months between the architect, structural, and MEP team in-house to coordinate every single opening. So, wow, I would like to tell you the engineering challenge is huge. Coordinating 150,000 holes is just as huge.
Yes, and to add to Luke, it was a compromise in design. Not everyone could route their pipes or ducts exactly how we initially had drawn it, and a lot of times we would have to reroute things to help to work things out with everyone. The next topic was something that typically a lot of times with shorter buildings we don't deal with as much, but it's creep and shrinkage. So Burj Dubai, per our structural engineers, over time the building would shrink a little. So typically the design was to allow, this is the design for them would have almost 1 millimeter per 1 meter of shrinkage, which would take almost a meter off the building over time.
Yeah, if I may, that is the reason, because the structural team has decided to use concrete, right? As we talked about earlier, if this is a steel building, then that will not be as big of an issue. But if it's a concrete building, concrete, once it start cure with time, it will start shrinking. And that's kind of the issue here. When you think about it, almost close to 0.8 of a meter is a lot of room to shrink. So, but it's the reason of concrete building that create this issue that are more particular than otherwise a steel building would have.
So, so on the here you see a typical design where you have a core wall, you have a vertical pipe, and then a horizontal pipe that goes through. And then as shrinkage happens and we don't account for it, what will end up happening is you have a pipe break, which will cause a lot of angst and grief with the client who owns the building, and then with all the residential owners and even the hotel operator. So the reason why this is also important, which I'll add, is I'm sure you can't see the slides very well because it's a very tall building, but we had pipes on the project. If you see on the left side here, these are the 2 fill lines. So basically we're taking water from the basement level, B1, and pumping it up to level 73. On top of dealing with what pipe materials we had to select for this and the pressures, it's almost a 250 meter tall pipe. So we had to look at these pipes in a special way, how to handle just installing it. And then for sanitary, we had a sanitary pipe, which I believe was cast iron with a vent pipe. And as you can see, from level 157 down to 42 was a straight run before it offsets down here. So we're talking about almost 600 meters in length. And then storm, similar, from level 154, almost 575 meters down to B1. We're talking about another 550 meters. Again, it's a cast iron pipe. but so some of these challenges, in itself, these pipes alone are as tall as some buildings around the world. So with the vertical risers, within the units, we had frequent pipe support and expansion and contraction joints. The main risers in the central core, we had pipe guides provided each floor and no gravity support. We had expansion and contraction joints near the top of the riser and full weight of pipes and water carried at the base of the pipe, which I'll show you some details now coming up. So this is the typical pipe support. We had the pipe supports here on each floor. So you had the guides, you had the sleeve to the slab, and then on top of the sleeves, we had these friction clamps that were joined together to help support the pipe. And then here, which is this detail here, which was done by Victaulic, with the help of Victaulic, we worked with them, was to provide some flexible couplings to allow the pipe to move up and down a little, and as the building shrinks. And another detail we had, which is a typical base riser support detail. So if you have these, this is for the water pipe. So if you have a 200 millimeter pipe that comes out, we would have had to have a support that attached to the floor. One of the, I'll say, I mean, while we were coordinating this, one of the issues we were having was you have a pipe from below that would come up and want to go out, and another pipe that's, you know, coming in from the mechanic, like from a pump coming in and going up. So one of the challenges was, how do you, with the mechanical floors, how do you account for space and allow the pipes to come up? So in many instances, some of our MEP spaces were getting very tight because we couldn't have pipes from different zones stack on top of each other. Okay, so one of the, as Luke mentioned, sustainable strategies were things we introduced in the building, but at the time, I don't think we were necessarily thinking like how we think today about saving water or reducing water consumption or reducing energy consumption. But at SOM, a lot of times we do this naturally, and it ends up being some of our design is ahead of its time sometimes, because in Dubai, they were not thinking about saving water. So one of the major water saving strategies was, from the HVAC side, was we did a condensate recovery system. The water that we'd collect water from the HVAC, it would come down into a tank here, intermediate tank, and then from there it would go down. We would run it through heat exchangers, which I'll explain later, which was to help cool the domestic water. And then we would collect this water in an irrigation tank, and we'd use that as makeup water to provide irrigation for the site. The other thing we also did, but it was not a big water savings, was we also collected the PRV drainage from the, so when they test the PRVs on a yearly basis, we would be able to collect that water as well into the irrigation and use it. But the water numbers were not that as bountiful as the condensate recovery. So here's the slide that HVAC and Luke and his team calculated. So we were able to save about almost 10 million gallons of water annually, which is about 37,000 cubic meters of water. And on average, the daily was not as much or as bountiful, but it's a little over 6,000 cubic feet of water, which is about 24 cubic meters of water. As you can see the chart here, the more humidity we had in the air, the more moisture we can collect. Now, I just want to show a little concept here is one of the challenges we had to deal with initially was in the summertime, the incoming water, cold water temperature for the buildings would come in around 40 degrees Celsius, which is about 104 Fahrenheit. And we had team members had gone to Dubai and had noticed that when they go take a shower, the hot water was really hot, and the cold water was hot, and it didn't matter whether you had hot or cold water, you were getting hot water, and sometimes people wanted cold water. So one of the things we looked at was how can we reduce our energy consumption by cooling the water. So we looked at introducing which I'm sure Luke will be able to explain a little better, but we have heat exchangers, one for the residential, one for the hot water, where we'd return the is it the chilled water return, Luke? I believe the chilled water, and it would be able to reduce the hot water temperature by a few degrees. And then we would be able to provide, and then which would not affect the return temperatures of the HVAC system too much. And what this allowed us to do was get the water a little colder than what other buildings in Dubai had. And another thing we also were able to do was instead of cooling down all the water, we would only cool down the water that was intended for cold water. So anything that was hot water, we would take automatically from the city, run it through heaters. And what helped us was in the summertime, our delta T was only going to be, say, 40 degrees Fahrenheit. So going from 40 to 60 Celsius. And we know in the winter, the water was a little cooler, but at least we were able to save some energy on that design. Another thing that was introduced in this project was at the time we were not necessarily looking at it as a resilience strategy or anything to counter to 9/11, but specifically to 9/11 or any situation. But some of the stuff we had introduced on Burj Dubai has ended up making it, I believe, into codes that are used now for many high-rise buildings. So one of the things on the plumbing side we did was, as you can see here, this is a blow up of our main riser diagram for domestic water. Was we had dual compartment water and fire storage tanks. We had 2 risers that come up the core and feed into the tank. Now, as you can see, these pipes are sized for 200 millimeters each, which is sized for the fire side and not the domestic water. The idea of having 2 pipes was, which I'll show next, was so that if one pipe was damaged or one pipe was was under maintenance, we had a second pipe that would be able to handle the load to supply the water for the fire and domestic side. So here's a typical core. I apologize, the building is very large and it doesn't usually fit on these nice presentation sizes. But as you can see here in this little triangle here, we have one pipe that fills the tank is located in this core area. And then here in this area was the second line. So we tried to keep the pipes separated and not in the same shaft so that if something happens in this shaft, we still have this water. And I just wanted to highlight for you guys where we had other plumbing systems. You had the storm riser here, the one that went almost 500 meters, and sanitary and vent here, risers. And just for your reference, these were sized for 500 millimeters, which I believe is probably, I don't want to say unofficially, I would say the largest pipes I've ever seen in a building. Typically 500 millimeters is reserved for civil and usually outside the building. For fire, do you have anything, Luke? Or?
Oh yeah, regarding the tank, one of the thing is we heard like one of the we heard from Ritz-Carlton that one of their issue was at one time the London hotel, one of the tanks start leaking. It actually impact, as you can imagine, if you have a large tank and it start leaking, it can truly damage a lot of floors. So in their case, it's over 10 plus floors getting impact because of the tanks leaking. So when we design these tanks, we actually has a containment tank on the outside or the containment structure on the outside, and we put a leakage detector. So anytime if the tank actually start leaking into the containment area, it will alarm the BAS system so people know that the tank is leaking. So think about if you have a gigantic tank in the building, how how do you avoid potential issue of the tank leaking in the nighttime when nobody is really aware is doing that?
Okay, and then for fire protection, I do want to mention that, which I probably didn't highlight before, but all the tanks are dual compartments. So if we had a tank that was 150 cubic meters, we had 2 compartments for 75 cubic meters. And in Luke's regard, so the idea was we would try to minimize if there was a leakage on one side of the tank, that we weren't going to lose potentially 150 cubic meters of water. We'd only lose the one compartment. And then for fire, anytime we had fire pumps, we always had a primary and standby on site. In case one failed, the second fire pump would be able to kick in. This was only installed in the one zone, as you can see in the top of the building. And typically, as you can see, we have the gravity system. Now we have express risers. Again, we had 2 of them, the idea which supplied each zone. The idea that if one failed, we still had a second one that can provide service. And here is just, I'll show you the enlarged plans, but typically this is on a lower level floor. We would have 1 sprinkler riser in this stair here, 1 sprinkler riser in this stair here. And for everyone's reference, on the lower floors, there was 3 stairs. Because the building was so large and the distances to travel. And then in the same shaft here that we had the plumbing risers you saw previously, we would have an express riser for fire protection. And then in this shaft here, where also we had the other domestic water riser, we also had the second express riser in here. Again, as far as apart as possible. And then I'll just show you the enlarged plan so you can see. So we have the risers here, here, and then this is the fire protection with the sprinkler riser, the fire hose cabinet, and the sprinkler drain. And then here's a vestibule, and then there's the stair. Another thing we looked at was PRV failures. What we were afraid of was, since we were working with high pressure systems and express risers and that would travel 30, 40 floors, was what happens if the PRV fails? So one of the things we looked at was, can we come up with a system to help alleviate the PRV failure so that there's no failure for this piping and any other fixtures and sprinklers and equipment down the line that cannot handle the excessive pressures. So the 2 things we did were we added 2 PRVs in line. So when if one fails, you always have a second one. And I believe on the domestic water side, we had the PRVs fail closed. So if this fails, it would close. It would not allow the high pressure pipe water to go through. And I just wanted to show you some details on the water tank and explain some of the strategies we did. So as you can see, I'll start with the right side here with the purple. This is what a typical tank looks like. In many cases, and you can't see, the tanks were actually elevated up in the mechanical level. So a lot of times we would have our equipment down here, which was very nice to have. It allowed us for some flexibilities. So this purple shows the tank, and then you have the 2 compartments that were separated. And as I mentioned earlier, if one compartment had to go down, we still had half a compartment to deal with it. And then when you look at it in this section, since these tanks were typically shared, you have one fill line that comes into each compartment. But then what we did was we had a system where you're not going to be able to see it very well, but this is the plumbing details. So what you did was you have a plumbing line that comes like this and goes down, and then down here you have the fire protection section, which is mentioned here as in a note. The idea is the item in green is completely reserved for fire. So if for any reason this tank never fills up, there is always some water in here for fire protection. And then the item in blue is what can be shared between plumbing and fire. So the idea was that if, for example, there was a fire and we needed more water, the fire would be able to draw the whole tank to use for fire and not just limited to the green amount, which So when we mention, when you see any information on Burj Dubai and they say we have water for 2 hours, in reality, that's the 2 hours is the dedicated for fire. But in reality, we probably have 4 to 6 hours worth of water for fire, if you include all the domestic water in the building. And this is a view, I believe, from the top of the Burj, right, Luke, where the antenna is?
Yeah, it is. It was a movie file, but I don't know whether, I guess this is a PDF. Yeah.
Yeah. And then,
Okay.
yes.
Yeah, and this is why we call maybe why we discussed whether this should be called as mission possible or impossible, because Tom Cruise actually take a picture at the top of the antenna, or in this case, it's actually the lightning arrestor. What you're seeing, those devices actually capture the lightning strikes onto it, where Tom Cruise took the advantage and took a picture there. The next slide.
I do want to mention, interesting thing is, from this, where Tom Cruise is sitting, to the highest, or the occupied floor, this is probably another 100 or 200 meters. So the person,
yeah,
if you want to talk,
yeah,
Luke.
yeah, go to the next slide.
So I was going to say, yeah,
so this is the latest video where they, at the same spot, they took the advertisement of one of the airline company in Dubai, and the lady actually standing on top. Now, I think if you look into the news, you will find out it took the media crew 1 hour to climb all that, just in the antenna itself, right? Not even try to get from the building to the antenna. It's just by trying to climb up the antenna itself. It took them 1 hour to climb to the top to videotape this sequence of the advertisement. So, you know, so I guess people do have great interest in trying to get to the top of this antenna to do advertisement, to do a movie, whatever. So anyway, so that was see you in Dubai. So with that, I think we conclude the presentation part of this. And we would love to discuss with you on questions you have or any discussion we can have together. Thank you.
Thank you once again. This is Prasanna. Good evening, everyone, and all participants. Thanks, Luke and Isaac Kusa. Amazing insight on MEP services, even though you touched a very tip of that, but it is amazing. Really, I know how much you people have enjoyed while designing this. One can imagine. Every information given by you is very much valuable. And our members in Indian Plumbing Association and other member associations have really got those informations for the designs. And we always say the plumbing is culmination of art, science, technology, and sustainability. This building is truly proving everything, really everything. So innovations are keep happening in modern plumbing to meet the codal requirement, challenges faced by building of high-rise nature, and more and above is the aspiration of users. They want really sky. Now you have seen that the video is taken onto the top of the antenna. So that is what the aspirations built into the developers. So we at IPA strongly believing in good plumbing system in any building would increase the life of the building and enhance the happiness quotient of the occupant and users of the building. I hope participants, you have greatly benefited from today's webinar. I can see questions are floating around, and I'll take up one by one and get the answers, suggestion, and the way forward into that. So there are some questions. I think it is in our chat box. Particularly one of the question which is saying the actual shortening of a structural building can happen, and what is that behavior of our plumbing pipes and system, how are we taking care? And it is to Mr. Kosa, and you did mention that there are joints, flexi joints which are provided. I just wanted to listen from you itself on this.
Okay, so typically most buildings that are concrete, that are, let's say 10, 12, 20 stories, the shrinkage is typically handled with the piping systems naturally. But when you get to taller buildings, the shrinkage, as we can see on Burj, almost was a meter long, or a meter. So some of the things we had to look at are, as we said, the joints. So you have to provide some flexibilities for the pipes to move vertically, right? So if the building is shrinking, it can move this way. And also when you have connections, you have to be able to provide some flexibility this way. One thing I didn't mention was there were some things we also had to do was pipe openings through structural walls. We maybe had to make them a little larger than they should be. So if a 4-inch pipe or 100-millimeter pipe ideally can handle a 6-inch openings, maybe we would come in and provide an 8-inch opening. So when the pipe is here, it might start here at the first day, but then it ends up down here at the next day, but it stays within the opening.
Yeah. I'm gonna add a little bit to that too. Yes. Now on top of the building, a concrete building will shrink. So in Dubai, the design temperature in the summer is 46 degrees Celsius, right? So if you install a pipe at 46 degrees, and depending on the circulating fluid temperature inside there, if it's chill water, for example, it could be around 5 to 8 degrees or whatever your chill water temperature is. So you're talking about 30+ degree delta T of thermal contraction. In this case, you have to account on top of the shrinkage of the building. So it's and on top of that, there are also movement, right? So it's the thermal expansion, it is the creep and shrinkage of the tower, or any movement that you account for on the riser side. And like as what Isaac mentioned, because you have horizontal pipe connect to it, so you do have to allow for the whole system to be able to move with all those expansion and contraction. And if you don't, and we have seen super tall buildings that either the horizontal connection or the vertical connection actually gets snapped, and as a result, there was water leaking into the building. So we have to be really something to think about.
And just to add one more thing to Luke, I think pipe material is also very important to look at. You have to design the system to what.
Yes.
You have to design the system to what pipe you had. So if we design it to a cast iron, so let's say like the drainage pipe was cast iron, versus someone else that wants to do a plastic pipe like one of the PVCs, you would have different design considerations to work with what Luke mentioned with the thermal issues and the creepage of the building.
Yeah, otherwise, what are the material of construction which you have used for the water supply, for flushing, domestic water supply, and what are the kind of water, first of all?
So on the water side, we tried to use, and this was not because we picked this material over another material, but we had to use a stainless steel material for the domestic water, because we were told that the water that was provided to us and provided to many buildings in Dubai was desalinated water, and they did not provide enough time to cool it and inject chemicals in there to make it balanced. So some pipe materials, such like copper, galvanized steel, were automatically excluded from any design options. So then you have to look at things like, okay, stainless steel, fiberglass, plastic pipes. And then once you look at that, you have to figure out, okay, what material can handle what. And at the end of the day, we decided for many of the high pressure systems and express risers, we had to go with stainless steel on the domestic side. I think at the end of the day, we had always recommended stainless steel throughout the building, but we know the client has cost considerations. And I believe at the end of the day, they settled on a PVC for some of the local domestic pipes within the apartments and the hotels. On the drainage side, we insisted on cast iron because we felt that there was nothing else that would be able to handle the vertical system without having to provide for huge areas for expansion if we use like something like plastic piping.
Thank you. And another question was, since you are handling the very high head water with a static pressure and dynamic pressure of the water, and what was your design consideration for water hammering and vibration happening due to your water supply pipe? That was one very interesting question because of the nature of the height of the building.
Okay, so typically, I don't think we looked at water hammer issues when we were filling the tanks from tank to tank because they weren't isolated within. But within the rooms, within the actual distribution, we had provided stuff like air chambers and water hammer arresters, and they were designed based to the industry standard, what's recommended by in the States. We use something called the Plumbing Drainage Institute, has a nice design standard, and that's typically what we follow here. So they would recommend, you know, the installation based on how many fixtures you have and what type of fixtures, and we just tell the contractor this is how you follow it, or we put it in our documents that way.
Okay. And
and I should also mention, and I didn't provide here, is we had a acoustic consultant that provided us with a lot of details to use for wrapping of pipes and this to reduce vibrations and noise transfers throughout the building, which
sorry, go ahead, please.
Oh, which I was going to say was, which was, I believe was unique to our project, and it wasn't necessarily always the standard details that you see or recommendations.
Yeah. And another question, sir, did you recommended or considered in Burj Khalifa for insulation for all the pipes, so for or whether it may be water supply, the sewerage, or the drainage pipe, basically what you call? Have you recommended the insulation for that because of humidity?
We typically, as a company, and we also look at the project, but typically we really don't care for the risers in the shafts if they sweat. What we're mostly concerned about is sweating and condensation occurring in the pipes inside units or inside areas. So a lot of times, storm piping is a good example where we might insulate it with maybe 1/2 inch or 1 inch of insulation from the leader all the way to the riser location. For water, we have to insulate hot water and hot water returned by code. Typically, we will insulate cold water. And same thing with drainage. We will provide insulation as required based on where we think condensation could occur. And usually we work with our HVAC engineers to figure out where some of these areas might occur.
So in this case, is exactly what Isaac talked about. The design temperature outdoor in the summer is 46 degrees C, 30% RH. Now, 30% RH doesn't sound too bad, but you got to figure it is 46 degrees Celsius on the dry bulb. So it's actually a lot of moisture. The condensation point is actually roughly around 20 some degree, like 25 degrees. So the indoor air conditioned temperature is the condensation point of the summer design. So anything indoor will get condensate in this case. So that's some things we should look at. Now, the other thing is interesting when it comes to condensation is the top of the building is about maybe 10 degree Fahrenheit, which we can do some math here. But so the idea is actually top of the building is much cooler and has less moisture. So if you really want to think about saving money, you can look at the different condition between the top and bottom of the tower to figure out when do you need insulation in your piping. But in general, the indoor condition is the dew point or the condensation point of the summer design condition outdoor.
Thank you. This is a very interesting information, because everything, whenever you go high rise, every stratification of temperature matters to every material of construction there. It's a very, very nicely answered, sir. So another very interesting question from Mr. Mukesh Asija. He is asking, do the local codes, that is UAE codes, permit protecting protection of building by gravity fed system? And
This is
NFPA.
This is the fun question. Okay, so technically, this building is not designed to any local codes, because for one reason, one of the major reasons is Dubai at the time did not have a high-rise code. Their local codes were not meant for such tall buildings, and even within the U.S., unfortunately, and around the world, there are not many codes that tackle, we'll call them, what are they called, Luke? Megatall, above a certain height?
Yeah, it's super tall, above 300 meter, and 600 meter is mega tall. So you can actually look around the world, not that many countries has design code for super tall or mega tall building.
So we had to look at model codes around the world, use our best engineering practice, and try to come up with something that would be better than the codes. But I mean, in reality, if you look at the tower, it is literally 40-story buildings stacked on top of each other. So we didn't, if we had to design this building based on local codes in Dubai, it would not look like this. And regarding for NFPA for gravity, I believe NFPA allows us to do a gravity system, but they do have slightly different requirements than what we introduced on this project. And obviously, everyone has to remember that when we were designing this building, we were in 2000, 2001. So a lot of the codes were from 1998, 99, 2000, and the codes have progressed so much since in the last 20 years to try to tackle some of these taller buildings, and also increase the resiliency of the buildings and whatnot.
Yeah, and the other thing to think about is when you have a gravity system, now everything connect to that gravity system has to be treated as emergency power supply, right? So you're gonna have to provide with emergency power monitor by your BAS system as a fire protection system, because all the transfer pump, everything related to that is becoming part of that emergency system.
And another question, sir, is what is the maximum pressure allowed in water supply line, and in supply as well as inside the units or inside the toilet, how much pressure was allowed? Probably that is the question somebody is asking.
Okay, so let's take a step back. So when we designed the system, since we were combining the water with fire to transfer up the zones, we looked at that system and said we'll follow NFPA, and we limited that to 350 PSI. I apologize, I don't know what the number is exactly in metric. And then within the units themselves, we would limit the plumbing zones to 20 PSI and 80 PSI, which I believe is about 170 kPa on the low end and about 550 kPa on the high zone, which is typically what we see in the States in terms of pressure. I know a lot of places overseas will not let us go up to 80 PSI. We've done projects where the local codes will only let us go up to 60 PSI, which ends up being like I think about 350, maybe 400 kPa. Now, the other thing that as designers we should look at is when we designed the Burj Dubai, since it was mostly residential and mostly hotel, most of the fixtures are residential style. So you have tank style toilets. They require low pressure. So the limiting pressure on the residential units is going to be the shower, at least for us in the States, which is at 20 PSI, as I said, about 170 kPa. But in the commercial setting, if you had offices, in today's market with the low flow fixtures, sometimes you have to bump that pressure up by 5 to 10 PSI. So the minimum pressure has to be adjusted to like 270 or 250 kPa as a low pressure.
So another question on drainage side, for a drainage pipe, have you used any velocity breakers or any similar type of scheme in the drainage system?
Yes, we looked at that because that was something the client raised. We did our calculations and we stand by the idea that terminal velocity will be reached after 3 floors, roughly 3-4 floors. So at the end of the day, it doesn't matter if you have 10 floors, 20 floors, or 100 floors, your velocity maxes out. So the issues there are not so much the velocity, but the issues would end up being something HVAC would be more concerned about, which is the stack effect, which I'm not the expert. Mr. Luke is the expert, and he can maybe talk about that a little more answering this question.
Yeah, so the stack effect is actually the height, the impact by the height of the building and the temperature difference of the air indoor and outdoor. So that will create a air pressure inside the building to move the air in and out of the building. So yeah, I mean, that's something to think about because the stack effect pressure could be about 400 Pascal to 500 Pascal in this building. So it can be a very high pressure in the air to create movement of the air movement inside the building.
So back to that. So the issues we will find is if you don't design that properly or you don't account for it, a lot of times we've heard stories of toilets not being able to flush, for example. And I think that's where the concern is with the tall buildings as opposed to how tall your stack is and how many break points you need. Generally, I would say if you want to break it, I'm not against it, but I don't think it is a requirement.
So another question is asked on the flexible joints. So what is the interval in which the flexi joints are provided for water supply? Are the flexi joints are recommended for drainage as well? That is the question, sir.
Yes, they're recommended for drainage, but to be honest, this is 20 years ago, so I don't know the exact details. But what we did was we sat down with Victaulic, and we explained the system. We explained the shrinkage, the creepage, and what they would do is they would come and work with us, and based on what they have available, they would recommend, for example, how many flexible joints you need. Maybe like a 100 millimeter pipe that was 200 meters long might need 2 flexible joints, but maybe if you go larger, you need more flexible joints. And it also would be accounted based on material you use. So on the domestic side, we use stainless steel. So it would still have the same strategy, but it might have a different type of joining method that they would provide. Whereas on the drainage side, if we use cast iron, they would have a different, it would be a different product. And I apologize, I do not remember 20 years ago what exactly.
I understand. Is a typical question on this one. These are all calculation dependent, depending upon the movement of pipe, the expansion, contraction, and many other things.
It is, yes.
One has to consider. Another interesting question, because they don't have any problem of power or electrical power in the building per se in a Dubai. But still, the uninterrupted power supply for all your plumbing system, is that recommended or designed or installed? What is that? You want to give information about UPS for the pumps?
Okay, so typically, if I was designing an office building, I would not put any domestic water on any emergency or whatnot, unless it was a client request because it's a specific building. Because at the end of the day, if the building loses power, you just go home and you go home, or you work and you just don't go use the bathroom, I guess, for a couple hours. But in Burj, since it's a residential tower and office, you can't tell people, well, we don't have power, go somewhere else, right? So one of the things we looked at is, do we want to provide power for the hotel and the residential and the executive offices? And I think it fell on the idea of us combining the fire and water transfer, that it allowed us to put the domestic water on emergency without adding any emergency power to the project and adding more substations on the electrical side. So we're able to provide the building essentially free emergency power for domestic water.
So
Right. And the emergency power is supported by the generator, not by UPS. The generator, once it kick on, probably take a minute or two before it get to the full speed. And we have, I think it's 4 generator or 5 generator at 2000 kVA. And then in the podium, we have a 500 kVA generator, low voltage generator supporting all this system. Now, one thing about high rise or tall building is, as like Isaac mentioned here, so if there are any issue in there, having water to be able to take a simple bath when there's power outage or cooling outage could actually mean survival to some people, right? You can have a lot, I mean, when it's overheating in the tower and you cannot get out of the tower, one of the simple things you can do is having water to take a simple bath to cool you down. So having supply of water during emergency time or during when there's power outage in the building could potentially actually mean survival to some people, because when you have 46 degrees Celsius outside and there's a power outage, the apartment could heat up really quick. So having some simple water to drink or take a shower could means a lot.
I should also add, we never presented this because typically this is not in a plumbing scope, but the way the building does the evacuation is people at let's say at a certain zone will go down through stairs to a refuge floor on the refuge space on the mechanical floors. So let's say there's a fire on level 80. So they will come and evacuate the floors above and below and take him down to the refuge. But there are people that are on level 40 that might not even know there's a fire at the top of the building yet. The strategy is not to evacuate the whole building initially. It's a staged thing. And also we use the elevators, which is another story that Luke could present or talk about. They use the elevators to evacuate people. So it's not, you can't expect someone to walk down 100 stories and get out the building. So a lot of times they're using the elevators from the refuge floors to take him down, which is called like a lifeboat operation. So by having a gravity system, you can actually provide domestic water during times of emergency without putting equipment on emergency. That's one thing. And two, you do have to look at the system and talk with the owner and determine what exactly do they want on emergency, what is a good thing. And just because the owner does not want something, you might want to, as Luke mentioned, talk to them and say, well, you know, this is a residential building. People might want to drink, want to take a, you know, I don't know, go to the shower, because it does take more than 2 hours to evacuate this building.
Yeah, Sushant, how much time we have? And I'll take a couple of questions before winding up.
Yeah, I think we have another 5-7 minutes, but you can see.
I'll take 2-3 questions.
Yeah, Luke, you can see we have around 50-60 questions are popping up. So I think you need to come up with another presentation for us.
Just
Yeah, let's do
pouring
it.
in. Questions are pouring in. We probably will take and will consolidate, send it to you for invaluable answer for us. That we'll do it later. Let me not waste the time. I'll take 2-3 questions within 7 minutes. Mr. Kusa, you mentioned the PRV drainage. What is that exactly PRV drainage is?
Okay, so you typically the pressure reducing valve will have a drain line to it. So when they run a test, they drain the water. And typically we would historically have drained it to a floor drain that's in the mechanical room or wherever. So we were thinking, why not try to collect that water and use it for irrigation? So we had a separate riser with an open hub drain, right? That you would take the drain line to it, and instead of collecting it and discharging it to the sewer, we would collect it and discharge it to the irrigation tank. Now, it's not a lot of water, but if you look at this building and you start saying, okay, let's collect condensate, let's collect the PRV drains. Personally, I would also look at collecting some of the fire line when they do when they do the fire pump testing. That's something I would also consider. It's not a lot of water, but if you figure, you know, if you have a 63 liter per second flow rate, and you're testing the fire pumps for 5 or 10 minutes, that you could get a decent amount of water so often, and you know, and whatnot. So that's exactly what it was. It just literally is the drain for the PRV for testing it.
Okay. So another question is, you did
Prasanna,
mention.
sorry, Prasanna, I need to ask one question later on when you are done. Just give me a time for a minute.
I do. One very interesting question, because all that consultants are facing day in and day out coordinating things. You did mention there are openings, 150,000 opening coordinations which you have done it. That is a humongous task. In any of the building, we may not be able to imagine the scale of coordination what is required. Here, the number of consultants, how you handle all those consultants put together. Whenever you are putting a pipe there, there is acoustic requirement. Whenever you are putting the plumbing pipe, HVAC will cry on that. And there is an electrical shock is always there as a consultant behind you. What was your experience on total coordination? What is the right method of coordination?
I can try to take that first. Part of this is when we deal with something this complicated, we gotta simplify it to a modular and standardize it. So when Isaac showed the openings earlier, we have a standard apartment openings. So unless there are differences or other reason we have to do it otherwise, there are standard openings in each apartment. Try to minimize that sort of work. Now, having said that, that only in the apartments level, right? Or in the apartment horizontal. Once you go to the riser, it's gonna be pretty unique in how they come out, and especially when they go out, you have to accommodate the movement of the horizontal pipe, so the opening has to be bigger. So those are unique openings we have to address. And of course, there's always the structural guys come and said, oh, we cannot put an opening here, this is our whatever, so you have to move those pipes. So that's why it took us 6 months to, in our case, there was, you know, during those times, like every day, the team actually come in is to face that drawing and coordinate with the structural and architect. Having integrated MEP, structural and architecture in the same office is important. Otherwise, you're gonna have a lot of issues just to getting the team together. There are a total of 30 plus consultants in order to collect all the hosts for everything, everybody, and make sure we address them. It was actually a logistic nightmare.
Yeah. Just to add to Luke's thing, a few things that we did that we thought was successful. Typically, when on any other job, when we're coordinating with structures, we, all the consultants, the engineers, we would come and say, we need openings here, here, and they would accommodate it. So you'd look at a structural wall section and you see a square opening, you see some circular openings, but it's not very clear what is going through those. You would hope that the general contractor can open up the plumbing drawings, the HVAC drawings, electrical, and go, oh, okay, I see where this plumbing is routed, where this HVAC is routed. What we did on this project, which is called the builder's work, is we actually had to assign the service running through the opening and tell them what it was. So if you draw a circular opening that was 100 millimeters, we would say plumbing, we would say fire protection, it would be IT, maybe HVAC pipes. In the larger openings, we would list what those openings were. So they had an idea of what was going through there and no one was fighting or thinking they were going a certain way. Now, in terms of the coordination process, it was 6 months. We would meet almost every day for 4 or 5 hours and do the coordination. What was helpful was you do the design yourself, and we would produce these drawings that we would all mark up, which we ended up calling routing drawings. So everyone would come in and highlight their colors on their own sheets. And so, like plumbing would be blue, let's say fire was red, electrical was yellow, et cetera, et cetera. And we'd come in and start coordinating. And once we finalized the routes, we would actually then the next day go back, update our drawings, print it again, re-highlight everything, and then we would give it to the architects, the coordinator and structural engineers, and they would literally roll up these drawings and keep them on the side. And that would be a record set as well as to the openings and whatnot. But yes, it was very painful. It's not done typically on every job, but sometimes it needs to be done to get the job correct.
Yeah, and the final thing I want to touch on is the C100 concrete is used in a shear wall. So in a floor slab, typically there are a little bit more flexibility because anything probably around 4 to 6 inch, if you really want to, you can still core drill at the floor slab, but definitely not on the shear wall. The shear wall, after they build a shear wall, I try to use a knife to see if I can chip a little bit of the concrete out. There's no success for me. There's no way you can do anything to the shear wall.
So it's very important to work with the structural engineers and come up with maybe additional openings that people can use down the line, or or if they want to change something, that they have access to get to that.
I can relate how much work has gone behind to look at that beautiful sculpture which your team has created. Amazing. Now over to Manish, you can ask your last question before we will conclude this webinar.
Hi, Luke and Zach. I mean, it's been more than 30-35 minutes. We have been doing a question answer session. It's a very big question answer session. My simple question is, why the fireman lift was planned only up to 130th level? Normally the fire lifts are taken right up to the top. So any specific reason for this?
Yeah, there's only one reason is all the elevator consultants we talk to in the whole world, nobody can deliver a fire lift that is higher than that. There are physical limitations too, because once you do a cable lift, once it's higher than certain heights, the cable will move with high wind speed. So you can feel it inside the elevator, and no elevator consultant was able to provide a lift high enough that the cable will be stable and the lift won't sway with the tower. And once they start swaying, it's very dangerous.
Okay, so that was the issue with the manufacturers or the lift manufacturer thing. And what type of ropes they use for such a high building?
The ropes? The cables.
The cables they use for such a high building to withstand the load of the lift.
I do not know the answer to that question. What I can only say is on high wind speed day, oftentimes the elevator has to be at a slower speed to avoid the movement.
And I do want to add, I think part of the limitations also is there's the requirement that the fire lift has to be able to go from point A to point B at a certain time.
Right.
So what limits it is speeds. And also, I think physically, the faster you have the elevator, for example, the larger your pit depression is, and your larger your overrun is. And at some point, I think it might factor in that it's not worth the effort. And also, I do want to mention if you're interested in elevators, Luke, if I'm not mistaken, Burj Dubai had the double stacked elevators, right?
Yeah, they have the double deck elevator.
Yes, the typical passenger elevators were double decked, which was, I think, one of the first buildings that really deployed it.
And also the elevator shaft, oftentimes for smoke relief, there is a van on the top to relieve the smoke from the elevator hoistway. In this case, there's actually a sprinkler head on the top of the elevator hoistway to prevent fire or to eliminate the fire inside the hoistway. And as a result, there's containment of this water to come out to avoid water actually going into the elevator. But in the bottom, we do have like this sump pit to pump the water out, and they are on emergency too, because there is a sprinkler head on the top to protect the hoistway.
Okay, so that was very important. That's very new thing which I have heard, because then it will create a stack effect. So that's correct. And can I take a last question?
Yeah.
Were any velocity breakers used for the drainage for this high building? Because basically you had mechanical flows every 40 floors. And what was the drainage strategy used for this building?
We did not do any breaks. We did not do any breaks unless we were required to shift the pipe based on a change in program. As I said earlier, we did the calculations, and we figured out terminal velocity hits the drainage after 2 or 3 floors maximum. So it didn't matter anymore whether you had 10, 20, 30, or 40. Now, what we had to consider was, yes, you do have a pipe that is 200-300 meters tall. Is how do you support it from the base, which is what we showed a previous detail. I showed the water version because that one was a little cleaner that I had, but the pipes would be supported at the base as well to the slab below at least 1 floor, so that it doesn't sway as much and stuff. So that's how we tackled some of those issues.
Now the only thing is you have to think about, if the pipe is open on the top and below, then it become a chimney, right? Once it become a chimney, now you have an air movement of potentially up to 500 pascal of pressure, and it's going to be moved down and out in the summer when the temperature is cooler inside than outside, right? So this chimney is reversed. Usually the hot chimney will draw the air in from the bottom and exit out from the top in the winter time. But in this case, it's a reverse chimney that the air gets drawn in from the top, down the pipe and out. And the pressure of the air pressure will be up to about 500 pascal. That's something you have to account for, adding to the movement of the elements too.
Okay. Thanks a lot. You can, Ishak. Over to you, UP.
I think, Luke, the hunger is still there. A lot of questions are coming in. So I think we need to plan a long workshop from you, maybe for 2 hours, to have more detailed information on a presentation, because the curiosity has really grown very high, because everybody's so excited, and the way you have presented it, it is really amazing. So I'm going to discuss on that with you later on that. So we need to have another big session planned with you. Thank you very much. Over to BOP sir.
Yeah, thank you, Mr. Luke and Isaac. Really amazing, mind-boggling for us who are designers. Really, they appreciate it a lot. Messages are pouring in like anything on our chat boxes. So thanks for the sharing the knowledge and the experience on high-rise building design. I'm thanking all the participants from all our chapter. IPA is having, Indian Plumbing Association is having about 25 chapter across India. All are watching this show, and they have had a very good learning time from these mega super. I'm really excited. I have no words. Such an explanation you have given to us, and thank Thank you very much, sir. I'm thanking IPA webinar team and for arranging this webinar. It is always for IPA HQ working team in the background relentlessly to put it all that program together. I'm thanking them. I'm thanking NEC and our National Executive Committee and the National Executive Board for inspiring to bring the innovative programs for our members. Lastly, not the least, I'm thanking and appreciate my webinar partners, Phenolics Pipe. They are the one of the largest Indian manufacturer of pipes and fitting, Grundfos. They are really developing the water solution for the whole world. Hewlett is our another sponsor and manufacturing high quality pipes, particularly on polypropylene. Kirloskar is one of the oldest pump manufacturers of India, probably one of the world's oldest, that I can tell them. And Willow Pump is the world's leading manufacturer. These are our sponsors for this evening. Thanking very much. And my request to Mr. Luke and Mr. Kusa, if you can make a paper for us to publish in our Indian Plumbing Today, a magazine, monthly magazine, that is the only magazine in India. We are happy to publish your do's, don'ts, or article on the presentation, what you made it today, sir. We'll be very grateful for that.
Yeah, we'll look into that and
Yes.
working together with you. Thank you for the invitation.
Yeah.
Also, I would like to request everybody, we are coming up next month, our Indian Plumbing Conference.
Yeah, I'm there on the,
Yes.
yeah. Yeah, and next month, please save your date, our members, the virtual conference of IPA on Thursday, Friday, Saturday, that is 23rd, 24th, and 25th of September. This will be our 26th IPC Indian Plumbing Conference in first virtual format. We will see you will see here from the very eminent speakers from India and abroad. Thank you, everyone. Bye-bye.
Thank you, guys.
Thank you, Isaac.
Thank you, guys.
Thank you.
Thanks a lot. Thanks. Bye.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye.
Bye.